myself Salil, works with IntelliGrade. I have around 7 years of experience like on various platforms, especially on Java, like J2, SE, J2, ME. Yeah, I'm saying J2 because the time I used to work on this, that was 2. Because yesterday Arun told us that it's not 2. I was, oh really? So that time it was definitely J2, ME, J2, SE, and now it's back. So now Ruby, Grails, and then a lot of NoSQL Word, worked on SQL Word also. Now like recently I have experience on Hadoop, that's why I'm here. So a couple of questions like maybe before this, like when Hadoop comes in front of you or any name, like what's the first question I would ask like in your mind? So first of all, like how many of us already heard about Hadoop? Have used it? Very good. I gained confidence. No. So actually used it as a development?
Yeah, that's good. Yeah. Yes.
Not. Okay. NoSQL you're already familiar. Yes. So, but I'm sure like people are already familiar with the data, big, large scale, the complexity of data. Because if I go back like 10 years, 15 years back, like maybe I was like I couldn't ask the question because the scenario was not the same. But now I can ask the question about the data. Like, so all we talk about all these things about data complexity, how to handle it, how to process it, and so here's the agenda for this session. We talk about what is Hadoop, why Hadoop. We see the HDFS architecture overview, like what is it, how it works, and then MapReduce. You know MapReduce. How many of you already familiar with MapReduce? Actually used it, implemented it? Good. I mean, there are few. Then we come like in the like from the starting, like we talk about a little bit my experiences from my project work, which I can say the case study. So, but yeah, in last we have a solid case study. Before that we have micro case studies. Not case studies, but yeah, just to have kind of examples. So then like who is using Hadoop and questions? Yeah, you can ask me questions in between, but it's up to you. If it's later, very good. So, okay, the background, like I'm sure like people already know these things, but that you just to get the things on the board. Like I want to have a flashback, what we used to have 5-10 years back. So my question to you, like open question, what is the problem with data? If it's large or it's unstructured, I'm not talking about here SQL, because definitely if it's large, beyond the limit, it's already out. Then, with the complex data, what is the problem? Has anyone tackled terabytes, petabytes? I haven't terabytes. Terabytes. The complexity, yeah, everyone knows that. So, let me take an example here, because this is that very bookish language. Let's discuss about an example. So before that, anyone like heard about vCards? vCards, nothing like this is. You can see. Oh, this is not marketing. It's about me and myself. I couldn't use like I thought like if I use anyone else's name, like they can sue me. So I use my own. So we get just nothing like just a text format for representing storing a contact. And this is not the whole thing. You can whatever comes into your mind, like you can store age, gender, address, notes, messenger IDs, whatever comes to. Like they have this is a standard. So there are libraries over here. So one library we just about to launch I will tweak of it when we launch it. It's under development. And because we are in current market, like there's no, we found like there's no very much mature library on vCards. We have, so that would be open source you can use. So after that, we are fine with vCards. Okay. Why I'm showing here, because I will throughout my discussion I will use this context, vCards. So it's better you guys familiar with. Okay. Let's say I have to process vCards, and I have some vCards with me. I have to fetch email addresses and social IDs. So they could be LinkedIn, but here I'm using only Twitter and Facebook. So we are using a good computer, like a single machine. It takes around 100 vCards per second. If I start, that's fine. Or I can reduce it, or I can increase it. It's up to you. 60 minutes for 1 million vCards. If it's 100 million vCards, it's going approximately 11 days. So, what's happening here? I mean, can you see something? Yes, the data is growing. It's already becoming tricky, a kind of trap, like if I'm on a single machine, if I talk about, not single machine, like, there's a complexity is also increasing. Because let's say if I'm running this job 11 days and 7 days, it just, crash out. Anything will happen. Hardware failure, power failure. I have to restart it. So, let's go ahead. Is it fine? So the problem, if I break into two parts, like what are the two problems here? Like I say one is the storage problem. Definitely, as the data is increasing, storage is also a problem. Like where to store it, how to use it, how to process it. Definitely, there are two problems of bigger. Like there could be more problems, but at least. So what is the solution here? Anyone? Yeah? Anyone else? Yeah, very good. We use it, actually we use it. We talk a lot about it. In all the sessions we talk about it.
That's great.
Yes, scaling. So we already know that two types of scaling. Scaling up, scaling wide. So what are the problems with scaling now? Is it the ultimate, the final solution? Yeah, it has solution, but still it has some complexities or some problems. So we discuss how and what. So I got solution scaling. Yes. Okay. So if we talk about scaling up, there is a problem. Like single machine always have a limit. CPU density has its limit. Then it always tends to fail. If you are lucky, that's very good. Maybe I'm not. So, and now, again, our problem is bigger if I use multiple machines. Because the multiple machines, the probability will increase to failure. Agree? Okay. And also, it's very hard for processing, like, it's not necessary that if I get a work done in 10 days on a single machine, if I set up 10 different machines with the parallel processing. So it's not necessary that I can done my work in 1 day. So dividing the work proportionally is a very hard and complex job. So we need a system now. We need a system to get out of this problem. So what this system is. Okay, very good. We definitely need multiple machines here to talk about cluster. And backup we need, definitely. And they should be built in backups. The failure probability now more. They didn't fail over. Let's say there's a failure, I don't want to run, restart the job. Then what I have backup? Everyone has backup. should just automatically. Something fails, okay, no problem. Let's go ahead. Now, next is parallel processing. It should be able to have some programming model. It supports parallel processing. Ability to distribute work proportionally, like, to reduce the complexity. So the output could be more. Like it could be possible to have that 10 days work on a single day with the 10 machines, or maybe 10 and a half days, but not 20 days. Yeah, it should be a single system. Like it shouldn't happen like that. I'm getting a distributed file system from a different vendor, parallel processing mechanism from a different one, because they will have a coordination problem. They could have, right? If it's a single system, we can guarantee that. There was a note on guarantee maybe. Okay. So if I say I get all these things in Hadoop, how about it? It should be flat. But actually there are more. This is just basic. Once you dive in, you will wow, amazing. And there are advanced things which are also building up and already built up. But here we only talk about the basics, the core part of Hadoop, which is this we are talking about. Usually it happens like I was talking to guys, I explained what is Hadoop, and lately is it a web application? I thought, okay, in the starting I will clear things. What Hadoop is not, that's the most important question. What Hadoop is not. Because that's why I'm asking what picture comes into your mind when we talk about it. Because mostly the web guys are using it, the marketing users, so all this picture comes, okay, it should something has related to web application. So, no, it's not a web framework, not an application. It's not a database, it's not a solution software. Right? Then what the hell is this? It's not designed for interactive web applications. What is it? It's a large-scale base data processing system. Like say you have huge data with you, and you have this data for 15, 20 years in your disk, and your archive of tapes, you go back. And now you want to utilize the data. Now here's a chance. Here's a scope. It was verified doctoring, and you want to read more about the history of, you can go to intellectuals of time constraint. And yeah, Google has a very good role here because he inspired from Google white papers. They already have their proprietary system they're using internally, and now they are also starting using Hadoop. But yes, the idea came from Google, from the MapReduce. That was the programming model introduced by Google, and also the distributed file system. So now, why Hadoop? So far, any question? Are we fine? What is Hadoop? Is it a little bit clear kind of picture, or you still have a kind of imagination about Hadoop? So
I learned what it is not. I think I will learn what it is not.
yes, of course. Good. Okay. Several advantages. Definitely, it's an open source. So it's your call. Like you want to pay, you can go to Cloudera. You don't want to pay, still you can go to Cloudera. They have free and community and enterprise editions. That's nice. It runs on commodity hardware. You don't need blade servers or very much like rocket sciences. Just normal machines, even on my laptop. So definitely a single package, having its own communication mechanism and so many things. Maybe may not discuss now. But yeah, there are so many. Like it's in a single term, I would say it's a single package. So everything is getting done over there. You are not dependent on another third-party solution. So everything is happening with it. Stores anything. What does it mean? Just
Give it a
blankness.
document, it will store a document. Give it JSON, it will store JSON. Whatever you need.
Yeah, I can use these kind of distributed file system, but I was reading about it and they were saying that there are file systems that when you put some data, they modify it because they are not saving it into the raw form, the binary, but it saves into bytes and all. So that's why whatever you save, it will remain the same. It's not changing it. It's not trimming it. Nothing. Wow. Now you are in safe hands. Already verified for leading internet companies like Yahoo, Facebook, Twitter, and Google now. They are very active into the development of Hadoop. So because they are using it and to run the show, whatever they are developing, the new features, they are just putting in the Apache Hadoop. Very active. It's proven at scalability. It's like terabytes of data already being processed per day on a basis like by Facebook and Yahoo. Yahoo is a great, or maybe the greatest user of Hadoop. It has many clusters, and the biggest cluster running on Yahoo, guess how many nodes it has? Single cluster.
100, 200.
For Hadoop, let me tell you that they say that Hadoop has three kind of clusters: small, medium, and large. The small cluster is 40 plus, 50 plus nodes, and with less than that, they said we won't introduce you. And then they said if hundreds of nodes you have, then it's medium. If then it comes to thousands, then it's large scale. So Yahoo is running like 3,000 machines in a single cluster. And that's for one cluster, and they have many clusters running like that. So you can imagine that how much data they are processing and how much data they have actually. Use with confidence. The community is very strong. You have a problem, you have a question, you raise it in the forums, you have a mailing list and everything up there. Tons of people like who will stand in front of you, give you the answer after me. So, in short, if I just, I put this slide, whatever I said, and you want, okay, tell me the only meaningful information about it. What is Hadoop? Like, maybe it's not in any book, like this is like what I figured out. What is Hadoop? Hadoop is robust, reliable, high performant, inexpensive. Definitely, it's not like blade servers or very big machines. And it's inexpensive, distributed data storage, and parallel processing framework. Clear? So if I replace distributed data storage with HDFS and MapReduce, like HDFS is Hadoop distributed file system, and parallel programming model is MapReduce. So these are the two parts, like core parts in the core Hadoop we will talk about. So the throughout the way, like we will talk about these two things, right? So okay, so Hadoop is HDFS and MapReduce. Now let's talk about the best way to think about to explain a distributed file system. Like it could, like I'm putting you here kind of into a scenario like you have so many machines, so many laptops here. The maximum, let's say the hard disk is 300 GB, and you want to store 1 GB, a single file, like 1 GB. How will you do it?
Split the file.
Exactly. So we break the file into parts. Like even in operating system, when it saves file, like it puts into blocks. But there's a difference between that blocks and Hadoop blocks. You see. So what I'm doing here, I will break the file into blocks. I will distribute blocks into multiple machines, and there will be index file which will tell, because otherwise the data is useless. It's just bytes. I can figure out which file is it. So just to know like what is it to make it meaningful data. So I need an index file. So here you can say name not is that index file, and here are your different like data nodes. You can say that these are different machines, different laptops you have. A VTAS or TXT is a big file having 50,000 or maybe 100,000 or million VTAs in a single file. So these files of this file. It say okay, save node 1, 3, 4. It is control of it actually communicates. The same node communicates with all these nodes. So So that's why it knows that where the memory is available now. So it says, okay, put over here. So here I will put my data, my blocks. So clear on the distributed file system, but it's not HDFS. HDFS, let's go a little deeper into that. It is. This is already there in HDFS, but there are more things in that. So let's see one more thing.
Question, here when the partitioning is happening, is that a size-based partitioning or can we do
You can, there are configurations, customized. Like by default there are 64 and yeah, the reason behind it is, now you asked the question, let me answer it. But Hadoop says that I'm not dealing with the lesser data, I'm always with bigger data. So it says that to save, the disk seed time, the operating system saves it can do 512 KB, so maybe lesser, something like 10 KB. So it says, okay, not less than 64 MB. So it's always good if you're dealing with Hadoop to have a bigger file. As big as you have, the faster performance will be. Just imagine that you have 1 million files with a 500 few KBs and a single file is a handle holder faster. So it's all about data. So it's by design, but yeah, end of the day you have an option if you want to customize it, you can provide it. That's right. So okay, so what Hadoop actually does here, HDFS says that, hey guys, I want to save block A because it saves block by block, not the whole file in a single go. So it says, okay, save because there's a replication in it because of the fault tolerance stuff and all. So and by default the replication is 3, but yeah, you can change it. You can have it to 1 if you are very, you have strong guts that your machine will not get failed. But otherwise, by default, it's good to have a 3 replication factor. So what happens is, so it will say that here, the interesting thing is that client will save only to data node 1. Now what's happening here? Can anyone figure it out? Any guess?
Replication.
Yes. I mean, what's happening here in replication?
The data from block A is going to data node 5, the data node 1, from data node 1 to data node 5 and then to data node 6.
Yes.
So each node is responsible for pushing the data.
Exactly. It's pushing it. So because bandwidth is definitely it's using 3 times. But the good thing is this: the client is not busy. It's now, if it's doing, just imagine that it's doing the replication itself. It could be slower.
So it's just delegating to the.
Yeah, they just delegate the job. It's okay, this is the data. Now the interesting thing is it's a pipeline actually. It doesn't happen that if file is once it gets done, then it starts. It's just pipeline. It's kind of streaming as the data is coming, as soon as it's coming, as soon as it's going. Right? Clear?
Yes.
Can I configure the number of nodes I want to replicate?
Yes. It's all like if you do the Hadoop administration stuff, like all the configurations file, it's always there. Like you can change the number of nodes, and actually it's rack awareness they call it. So we see it in next slide. I will tell you why I use 156. You will ask where are 2, 3, 4. Right, intention. Okay. So it's very large distributed file system, clear. I mean, why it's large? Like if you can store millions of files on it, you can have terabytes of data. It's proven, so that's highly scalable. Fault tolerant, we already discussed. It will have, the recovery mechanism and replications. Rack awareness 2 plus 1 factor. So it's interesting. What is it? Any idea? 2 plus 1. Again, duty. Yes. I'm using 2 terms here. 2 plus 1 and rack. Okay.
Server, like the number of servers that keeps the copy or something like that.
Yeah, you are very clear. So it's saying that it's rack awareness. Like you have multiple racks, and one single rack, like it doesn't do this thing like, okay, I have to replicate 3 and I'm putting all the nodes on a single rack. So what its intention is this, okay, I will copy only 2 nodes on a single rack and the other copy would be on a different, so that if rack gets, failed, so that you still have
I think there are configurations for the data center and the closed data center.
There are. There's always flexibility, but this is by default. If you are doing nothing, still you will do this.
So, let me take an example, like for an application. For example, I have a website, large website, where users upload photographs. Like photographs are like 2 MB, 1 MB, 3 MB files. I never want to lose the photographs because the users will kill me and they'll leave my site, whatever. So is HDFS a good solution for that? Because I am.
It's very much personal. I would say if you ask me personally, I would use S3, something like that. That actually goes to cloud.
But yeah, like
maybe
I want my own data center. Like I have 5 servers of my own. I don't trust Amazon or just a imaginary scenario. So like I would use HDFS as because what I'm trying to find out is what is the practical application of as a website. I'm a web application developer.
Oh, basically, if you maybe you are putting the Hadoop in a wrong place. I'm just telling you beforehand. You can use it definitely if you want to use HDFS. You can definitely use it. Even the S3 is a distributed file system. Yeah. So where HDFS I'm talking about is a distributed file system, but you can use it. You can use it. But actual work of Hadoop HDFS is processing. You have data. You get some value from this.
Okay, I'm not getting any value from it.
Yeah. But yeah, it's personal. You want to use it?
Because Facebook uses it. I think Facebook uses it for that.
HDFS?
Yeah.
For storage? Could be possible. They are big guys. I mean, they can have replication factor of 50. They can have 10 data centers, they can own it. If one goes down, they have still second, third. For me, maybe I don't.
Probably to answer your question, like if you want to do certain processing or images, then probably HDFS is the place where you
Yes,
use them.
yes.
If you want
You are.
real-time access to images, probably HDFS is not right.
Okay.
Yep. Right. So that's why it's an unstructured and complex data. It's complex. It has no format. I mean, there's a format, but the text MapReduce. Okay. There are many people where you can use MapReduce. That's good. So, from layman's perspective, we'll go deeper, like how it's very different from the other MapReduce, like people who have used MapReduce. So it would be very different, like Hadoop, how MapReduce works. I don't know, like if there would be any similarity, but yeah, there are more things. And actually many more things, but little more we will talk. Okay, so if I have a very big, huge project, like usually we do in the software engineering, we get a very big project, we divide into modules, and further in the modules there are sub-modules. In some modules we have multiple teams, we always, integrate and differentiate stuff, like we just break the things. So just imagine that you break the work, the nature of the work is same. So on all sub-tasks, you can implement the same function if nature is same. So here the nature, and ultimately from all those sub-tasks, if I merge the output, I get away. First I distribute it, then I get away. I'm doing the manager job. So I will have, I can get the work done in this way. So this is MapReduce, I would say. So in an example, if I would say that I have to process VCAT, and in VCAT I have to count the number of emails, number of social IDs. Social IDs like how many Twitter IDs I have with me, how many Facebook IDs, blah blah. So how do I do it? With the MapReduce. MapReduce. So definitely, quite close. Let's see actually like how it looks like with the Hadoop. Anyone familiar with the MapReduce? So can you see something different here? Anything? Okay. Or is it just normal? I would say different. Just observe what's happening. There's something.
Shuffle it.
Shuffle is, yes. What shuffle is doing? I'm giving you 10 seconds. Because I'm running out of time.
Does it give the reducer sorted data?
Yeah, you see one thing, here what's happening here, definitely nodes are, we have so many nodes, it's not a single machine. So if you see the Twitter, all the Twitter stuff is going on a different node. All the Facebook related things are coming to a different node. It's not that mingled. Other, yeah, exactly. So it's called, like, shuffle has 3 stages here. We little bit more talk about it. One is partitioning, second is grouping, third is sorting. Sorting is not done here because if I would have sorted, the order would have been 7, 9, 15, 33, right? So it's not sorting, but it's partitioned. Partition is saying, okay, go to this on the basis of keys. So it's just sorting the data. So that's partitioning. So how it does it? So all the people who work on Hadoop, they say the magic happens here in shuffle. And this is actually kind of a default implementation. No one need to use it unless you have really complex scale. Yes, sir. We will talk about it. Okay, so what's happening here? I'm getting a vCards, a quick what's happening here. So every vCard has some email, Twitter, and all. So what's happening? The mapper is like a whole node. It's getting, let's say, 100 vCards. So this is the result of vCards. So it's an email of 38, Twitter 9, Facebook 9, and everyone is giving this result. So now all get accumulated here, reducer. Now the distributed stuff is done. Reducing it here. Let's say total user is 185. Facebook this, Twitter this. Clear? MapReduce. Any question on MapReduce? You should be able to solve your problem with MapReduce. Alright, good. Few facts about MapReduce, like one is like very important. The reducer phase doesn't get begin until the mapper gets done. But yeah, partitioning starts. Partitioning starts immediately, even when the mappers are working. But the reducer only gets started once even the mapping and reducing is done. So mappers are done, definitely partitioning is done. Shuffle is done. So reducer can start work. And then it's a kind of practice. It's not a it's not a mandatory rule that when you're working on the Hadoop or MapReduce, they say that if your tasks are interdependent, it's good because otherwise it would be the processing kind of poor processing. Okay, so maybe yes, still it's a personal decision. Okay, definitely if any task get failed here, so MapReduce, like Hadoop, has a kind of a job tracker and task tracker. We are not going into the depth of that because that will take another 2 hours discussion. So just imagine that if some task fails on some node, like a vCard fails, so what will happen? Ultimately, the task will be like if node fails, the task will be handed over to different nodes. So this way, the failure will be handled. Is it clear like how the fault will start? Any question? So you are clear, right? That's how it works. So that's why, yes.
What exactly are you mapping?
What exactly is mapping?
What is mapping to keys? The subtask is mapped to the keys.
Map is like the division of work, I think.
So where are you pointing at?
You're separating it out as subtasks.
Yes.
You're giving it to shuffle after shuffle.
Right. So here for the mapper, see, this is always key value. If you see from starting, like when even there's a question mark, it's not actually question mark. It's key. And why it's question mark? Because for this job, I really don't care about the key, but I know what is the key here. Actually, I don't need it. I'm just talking. I am caring about the content which is in the vCard. So that's why I just usually if you for the MapReduce job in Hadoop, by default, what happens if you give a text file? A MapReducer works here. This is like line by line. It gives you line by line. You got it. Like, a text file with 1,000 lines. It will get 1,000 lines. 1000 dimensions. Line by line, this is the default one. But here, when I'm working on VCAR, so VCAR itself has, a format. If I take a single line, I will mess up everything. So here are the options in the Hadoop. Like I can define my own formats. I can say, okay, this is my input format. It's a VCAR. The starting format is this, ending it format. So automatically split the file into VCAR. Let's say there are 1000 VCARs. So now the line number could be 1 million. Anything. So it will just quantify that. You just see it. It's giving me the whole VCAR with using that input format. So now usually that is the line number, the first key. Or here you can see it's an order, like which input split, which order is it. So it's 1, 2, 3, 4 like that. But really I don't care here because I don't need it. So the VCAR is the key, and then again it's a mapping, it's key value here. So here it's saying email is a string here. String. I don't know if you got other language in Java here because string. Text. It's text. Twitter text, Facebook text, and 38 lines is a count.
So in every MapReduce, implementation, you have these two steps, mapper and a reducer, or is that Hadoop MapReduce way of MapReduce?
Usually, like MapReduce, exactly it works like this. But there are more things like implementation is totally different. How Hadoop has implemented, but the concept is of MapReduce is this is that we distribute the work and we divide it and we gather it.
And the shuffle, that bar that you have, is it specific to this use case, or is it also something that would happen in most of the?
Shuffle always happens internally in Hadoop. Always, because the whole world Hadoop says that the magic happens here.
Okay, that's the objective.
But that's a default implementation actually. But yeah, for kind of sometimes we get kind of work maybe I will talk in next in the case study. There we need this stage. There are like the APIs provide us a way to give your own implementation button. So we see how we do it.
Okay, just start there. If I try to understand it in layman terms, let's say there's a chunk of features to be implemented, and let's say each developer is given 3 features.
Okay.
Let's say there were 30 features to be implemented, and you had 10 so-called mappers, and you gave 3 features to each developer. Then what's happening after that? Let's say, okay, I understand till this point that there's some partitioning that was done. Then there was some work allocated to each mapper of sort. And then after that, what's happening?
What's happening here?
I try to map my use case.
Now, when they get the job done, there would be some output from their side. Let's say they are giving you job, right?
And they don't know patches, let's say.
Right, yeah, patches. And they don't know about, they just know about their work. They are not sure about the whole work. But there should be someone who knows actually how to integrate.
Yes. When they commit it to their SPN or Git, that's when they are reducing it. All jobs.
So sort of like there's a Git admin manager who says that you submit your jobs, you submit your branches to me, and I'm the one who is merging it into the main development branch.
I mean, I expect that to be one instance. Why are they, multiple users?
So that's why Hadoop, if it's one instance, and I have to process terabytes of data, and Hadoop is again like it's all about the nodes cluster. So the performance will be slowed down. Even the memory won't be that much on a single node. So how it distributes them, even the reducing task, you can say that there are many. Oh, one more thing, like in this, like I didn't have that much space in this slide, so I wrote the output here. So actually, there's one more stage here. Like you say this, and this. You're talking about that. There should be a single one.
Right.
I'm sorry, I got it now. So because of space, like I couldn't do it. So ultimately, these 3 will come together into the HDFS. Right? So you can see the final testing. The starting body is HDFS, the ending body is HDFS.
So in your example, what you're trying to do is that you're trying to find out how many Twitter IDs we have or something like that?
Yes, yes.
So ultimately we reduce to the fact that whatever we got and passing in.
We run it on a demo, like I would have around
Yeah, sure. Well, like
400,000 recards.
Uh,
I have on my machine, so I will run it and I will calculate in a few seconds.
You can do whatever you want to do with this data.
Yeah. But yeah, internally, like you cannot see it when Hadoop jobs runs. You cannot see there what's happening there. Even I can't use printer and stuff. So, but yeah, to explain it, I just do it. Should I?
Let me ask you a little, maybe a relevant question here. Let's say if the same Twitter ID is repeated in 2 recards, will it be counted?
Yes, it depends on nature of job. Like the one I am showing you for demonstration here is definitely it will show that it's counted.
It will be counted twice?
Yeah, but yeah, definitely you can handle it. That's the kind of program like how
the logic you're writing in your job.
Yes.
So in that case, two nodes will not be aware of it.
Reducer just helps you in that. You can have a custom plugin for your reducer for your networks. Or you have that reducer level or the final converter.
Yeah, sort of. You can play with key here. If you have a key like Twitter and name of the Twitter ID, then definitely you can know that who is this guy. And then you can have kind of forget thing. Because the whole magic depends on how you design it. The Hadoop is nothing, it's all approach. Even the case study we talk about is all about approach. I'm very excited about that.
Just one question here, sir.
Yes,
The
yes.
map output, like what is the map output? It says string email and then a count of IDs against it. So a single record is a single ID, right?
Yes, but that's a kind of one mapper task on a left hand side. But here, to be very honest, it's very hard to show you the whole Hadoop working on a single slide. So, but the best way I could figure out, but I'm telling you, that's a very valid question what we are saying here. So, on left hand side, there was a single task, but on right hand side, it's a combined output from one single node map. So, let's say it processed 500 tasks or 500 recards, and from 500 recards, it figured out total emails were 38.
The mapper would not be actually counting, right? Mapper would be just simply splitting the output.
Actually, mapper here is it's representing actually a node, a machine. That's like how many recards went there, but that is a mapper task. So I try to mingle it, both the things, into a single picture. So here, this mapper is saying it's node, and here on left hand side it's saying I'm a task, and right hand side it's saying I'm a node. So it's behaving both ways. Yeah. I'm sorry about the presentation here, the drawback and the direction, but I could just think about, because otherwise it's very hard to draw on a single, and because also Sangeeta was telling me that have a bigger size of images, otherwise people can't see it. So I drew very hardly. That's about it. But yeah, if still you have questions, maybe I can show you on entire code, or maybe in a data, or maybe I can draw how it happens. Let's go ahead now, because how much time, I don't see how much time we left?
10 minutes.
Only? Yeah. Wow, man, how about the demo? The class is out?
We can.
So, okay, we already case study. This is something very good. Okay, so what is it saying? Identify and merge contacts. Maybe you get your doubts clear here, or maybe you get more doubts now. There are both way possibilities. If you have more doubts now, we can talk offline. If you have less, that's good. Identify and merge contacts. What does it mean? We are talking about recards, and we see what does it mean. Here are sources. Sources are like, these are different services who provide recards, and service A has vCard, which needs what is in vCard C. They all are trying vCard, but they are fully independent from each other. They do not, service C doesn't know about service A, what they are doing. So, but I have a single system here. I'm just putting all the vCards into a single place. Now what's happening here? It's quite possible that Harsha's recontact is coming from source C, and Harsha's recontact is coming from source A, source B. Everyone is giving Harsha. Service C is saying, like, it has Twitter ID of Harsha. Service A is saying it has LinkedIn ID. And if I'm a good service provider as an integration. So what I would do, I know that I will somehow identify, these all vCards of Harsha, let's combine it and make a big vCard which has all LinkedIn, Twitter, Facebook, everything what you want to get about Harsha, I will just do it. Correct? So this is identify and merge. So wow, now the question, how do you do it? Simple. We are a program. And yeah, that's very true. But still, what's the approach? See, here we talk about like how Hadoop is all about approaches. So,
Reduce and reduce again.
how do you do it?
To be reduce and reduce again.
How do you do it? And this is that's what you are near. But what's the general way that we do it? Maybe like definitely if I talk about myself, I stood up, okay, I will do it. Okay, I have 100 vCards. I will go through, okay, first vCard, I compared with 99. Then the second vCard, I compared with 98. So we have formula 9 n into n minus 1 divided by 2. Any mathematician? Yeah. Right? Okay. Now, let's see what the problem here is. Any objection here? See, I am assuming that you are using very good machines. 1 millisecond per loop is comparing 2 vCards in 1 millisecond. Very good machine. Still, it's taking 2 months for processing only 100,000 vCards. Man, I cannot do this business. Moving out. Make sense? And it could possible, or maybe it is possible. We have more than 500 million vCards. Keep on increasing. Man, I'm going out. I have to take 7 lakhs and see if it will not be done. And if it fails in the meantime, who will be responsible? Okay.
You won't be responsible.
I'm not. Technology will be responsible.
Whoever designed that system will be fired.
I will be fired from my life
But only up
in
to
3.9 million years. Alright, so yeah, definitely I cannot show the whole thing here, but my objective is to show like how it works, like such kind of scenario, like to talk about the approaches of Hadoop, like how when we get it work, like how should we think? Because Hadoop, it's not like we can deal with the same way. Like I won't go with the n-1 like way. There are different approaches. I will use some different approach here, and that would be look a lot more faster. But why? Okay, let's see. So here's an example data we have. vCard 1 says, I'm just taking example of emails here, not Twitter. You can use Twitter, LinkedIn, everything you want to do. You are just normal vCard. But just to render the thing, I didn't want to write the whole thing. I'm very lazy in this. I just pick these things. So, and we all are smart like that. I say, oh, V1, V3, V4, they are same. But machine is not. We have to program it. It cannot judge it. Like with a human brain and I can judge. Okay, V2 is, there's no similarity with V2 with any other vCards. But V1, V3, V4 has some similarity. I can figure out, okay, this is the same person on the basis of email. Agree? Any conflict?
No.
Okay. So actually, to do this, there are many ways, and it's definitely personal to like how you want to go with it. And also, from my perspective, I would say it depends like kind of quality of data, or vCards I have, and number of vCards I have in my system if I am going to access it, because that matters. That what kind of approach I'm going to use here. So it's really very important to understand about the data, about what's happening here when you want to work on Hadoop. It's not like learning Hadoop it's nothing. Hadoop is just two things, I would say, the core part. MapReduce you already learned. Distributed file system you already learned. But what is important here to learn how to design your jobs. That's I want to explain here. So the approach I'm talking about it. See, you can get this work done in a single job, in 2 jobs, in 5, 8, or maybe infinity jobs and work complicated. It depends like how you're doing it. So here the approach I'm using here will have 2 jobs. Okay, the first job. How much time do we have now? That's
I don't know, pressure.
that's fine. We can finish in 1 minute. Okay, so here what's happening here? In job 1, if you see that. Yeah, exactly. This is MapReduce. Yeah, you actually gave me the answer. that is correct. Without MapReduce, definitely I cannot do it. But the only thing is this, even the approach is different. See, this is not fair. The way I was talking about was n into n minus 1, and there is no n into n minus 1. But I try to do it on Hadoop by doing n into n minus 1. But that's not possible on Hadoop. But the good thing about Hadoop, if you see, that it provides me flexibility to handle this kind of job in Hadoop. Like on a single machine, I cannot do it. I cannot do the same approach because this approach is giving me like I can have if I have 100 million records because it will just replicate it, this approach, and I will have maybe 500 or 600 or maybe 1 billion records with the replication because it's mapping then reducing. So on a normal regular approach, I cannot do with that because my hard disk will crash or anything will happen on a single machine or exam. So it provides me flexibility here. So what are we doing here? Is it understood? Can I say it or I should explain? In the job 1. But I'm explaining. So what the mapper is doing here, we have email 1 and we're just writing the whole vCard content in the key. And on the top of it, if you see in the top in the yellow highlighting background, saying that generate hash file because you see that there is no ID actually in vCards. But I'm trying to say here, like we didn't have any ID here for vCard, so we are generating like just to identify it. So we are generating the IDs and we are putting it back into. Okay. Now I modified V1 a little bit, so that's why I used that. Email 1 and you just you just see that for email 1 is the key, email 2 is the key, and writing the whole vCard again for the same with all the emails, and just if there will be 5 fields, there will be 5 times I will write the vCard. So now what's happening here is here. Now what I'm doing, somehow you figure out that with the email, like who has the same email, they will all get together. V1 and V3 had the same email, they came together. And this way, I can do the first part of merging. Any question? Okay. Then on the reducer part, I will merge these and I will keep the reference. 1 and 3 get merged, 1 and 4 get merged, 7 get merged, 3 and 4 get merged. Fine, this is the end of job 1. Now, here we have job 2 and partitioning plays a very important role here. And grouping, definitely. Now, what I'm trying to do here, see, it depends, like, if I have a lesser number of V cards, I can go with this approach. But maybe if I am going to process 1 billion V cards or 500 billion V cards, it could have a problem because I'm working on a lesser number of nodes. I cannot go far because here the approach I'm using here, I'm saying it, because I'm following here the 80-20 rule. Like, we see that in the 80-20 rules, like, we have V cards, in a 100 V cards, we assume that 80 V cards are kind of unique and 20 are they will get merged. They get duplicated. So with the 80-20 rules, like I can go like I can have 5 nodes, and I will say, okay, single node is for those who will get merged, and all the nodes who are already unique, they will just get distributed everywhere. So here on a single node, I will use the group comparator. We can say, okay, so these have similarity from the keys. Like the 1 is there, 1 is there. Okay, this has similarity. So it will just get from the group comparator, it will get all the nodes of V1, V2, V4, and any doubt here, V2 is getting separated here, and all the get, and finally I have out here. This, but yeah, I told you, it depends like how much data you have and how you are designing your job. Because other way could be we are doing somewhere, and there we are using some database for mapping. Like people gave like a presentation on Redis. You can use Redis as a key mapping. They will figure out because it's very fast. The only problem with that approach of database, introducing a database, it can make it slower. But yeah, if your database is fast like Redis, I guess, and I will try to put Redis here. But yeah, here this is more. But these are other drawbacks. I cannot process. I cannot go to many more nodes. And there are other approaches. Like you can have n number of jobs by having the output formats. You can keep on rolling the job unless it is done. Like what it will start doing, it will, okay, I know the V2 is not getting merged into any V card, so it will say, okay, let's pull it out. It's already unique. It's already unique. And the one which has plus sign, which are already getting mixed with other V cards, they'll keep on rolling on that until they're just and in that way, I will just start deleting the the other references of that. So until there will be similar. Maybe it's very complex to explain every but yeah, the thing is I went through the whole thing, so that's why it's straightforward in front of me. Oh, you got anything here?
Question. You were processing like 1 million V cards or whatever the number, and the reason why I'm tying it to my earlier question was around the sizing that Hadoop does. So 64 megs,
Yes.
what you said is the default size that it takes partitions into.
Yes.
So if my file is terabytes, it will be broken down into 64 megabyte chunks.
Yes.
Right now, wouldn't certain V cards be split in between, and how would I even kind of reconcile them later? Like I have 1,000 chunks now, and since there is no, and that is the reason I was trying to ask that, is there a logic in chunking so that the V card does not get kind of chunked in between and then I have to reconcile that back?
Yes, because this is a very valid question. Anyone? How would you do this? That's what
We were talking about that splitting.
Yeah, we said that if the file is huge, terabyte, and how the HDFS client would get to know that where to divide it. If
So that the data.
yeah, if it gets cut in between, like not from, because we are not providing any format to. So Should I answer or anyone? Try to.
Yes, answer.
Okay. It's very much personal. Not personal answer, personal approach, personal decision, how you design it. Because here,
So network, can you provide a splitting logic or?
no. So it's my responsibility. What I will do, I know that what is the size of my blocks. I will try to have a little smaller size file. So what I try to do here is, I know that this is the size of the card usually is general. So I will not have more than 50,000 cards in a single file, so that it won't get.
But if one B card gets split in between, that's what.
No, it won't. The way you are storing, see, if you are already having a one, like why should I have 1 terabyte file if you know that other way you can increase the size of your blocks. You know that's very good that you have 1 terabyte kind of file size. You can have 500 and.
Yeah, possibly, but generally, probably this will work for structured data. For example, V card I assume is a structured data. For unstructured data, it is you don't even know where and what is the box like. If I'm say parsing Twitter feeds or Facebook feeds, then I don't even know what the feed length is. So in that case, it just becomes very unstructured. Think about any logic for splitting. V card possibly yes.
See,
but I'm just thinking aloud.
To be very honest, maybe there could be an option or possibility of telling them to HDFS client, like because their API is always available for that. But I never use those APIs because I just use the default client. I never submitted the data through programming interfaces. But yeah, definitely there could be an option that they can tell that. But I never went into that side. So usually, like what I do, I just put by running the console commands like the job, or you can even use the S3 directly to get the data there. And it's definitely, it depends again your personal decision how you design it. And but yeah, in my case, like what we do, I try to have size less than that. So we do not go like more than 50,000 cards in a single file, and that works.
Yeah, because
And if you
splitting the
other thing I would say, like I talked with this guy, he was very bold and very good businessman, like in terms of hiring, like he's with a couple of startups, very stable. He said, I don't care about the minor things like this. If he knows that 1 million V cards are proper and one is selling, that he said, I don't know. Again, that's a personal decision, I would say. Answer is not personal. Wow, I guess. Thank you so much. So these are the guys, like you already know that there are many guys who are using already well established using Hadoop. Like the most heavily used are Yahoo, Facebook, New York Times, Brightspace, Last.fm.
I read a couple of days ago, but I just read a little bit of it that there are some issues with MapReduce, and Google is coming up with something called I think Camel or